Here we go. Give me an object to draw. First of all, turtle. Nice. This is a turtle.
That looks like a snail, Mr. Franklin. Oh, that's a tail.
Turtle.
Oh, I thought that was.
I thought, okay, that makes
It's a
sense.
turtle.
I thought the
Sorry.
rat was his head.
There. That's a turtle. Thank you. It's a good turtle.
It's a turtle now.
Let's make this a giant turtle. 50 kilograms. Wait, I don't know what that is. Let's say 20 kilograms. 20 kilograms. There. Still a very big turtle. I think this is not like a giant turtle. Maybe it is.
Tortoise.
Tortoise. This turtle is not on the ground. This turtle is being lifted by a helicopter. Helicopter. That's a helicopter. What's this then? What's that? It's the helicopter with this little stabilizer back here.
Okay.
And
There you go.
that's not, this is not water coming out
That's
of
all you
a,
gotta do.
That's all. You just-
whatever
We
the,
had to add that
Blow
one
hole
thing,
there.
see?
Okay. It's a helicopter.
Helicopter now.
This thing is applying a force here. Let's calculate the weight of the turtle real quick. We know how to do weight now, right? Weight's a force, so we'll use the force formula. This is an earth turtle, not an alien turtle. I guess that's it's a very small helicopter, huh? Because if the turtle were this big, then it'd probably weigh a lot more. Maybe it's like a parade float turtle, like it's a blimp turtle.
Maybe the turtle is carrying the
It's
helicopter.
like a balloon. Maybe. If the turtle's 20 keys, that's our mass. If we're calculating weight, we're looking for force, so I just write F. Alright, so we got 20 keys for M.
192.
Hey?
There's 196 or 192.
Yeah, we're gonna get there. We're gonna get there. Acceleration, we're on Earth, so when we're calculating weight, because weight's because of gravity, we use the acceleration due to gravity. 20 times negative 9.81 when going like this for some reason. So that's right, it's negative because we use negative 9.81. People are messing up their negatives a lot with this. Be careful. Yeah, 196.2, or we're just going to say 196 just so it's a little easy. A little easier. Let's say that the helicopter then is pulling up with 200 newtons. It's a very small helicopter, okay? Yeah. It's just so the math works, I guess. Very small helicopter. What about, let's make the turtle being pushed one way or the other here. I'm not going to make this more complicated. There's something pushing the turtle. Let's say, I don't know, the wind in one direction. How many newtons is the wind pushing the turtle? Let's make something up.
2.
2, okay, 2. 2 newtons. And then let's say friction the other way is 1 newton. That'll be fine. Okay, so cool, we did the weight. Let's see. There is a couple of questions on this assignment that y'all will do that ask you to draw something like this, or it's already got something drawn, like maybe not quite like this. This is special. But it'll ask you to draw it again with just the net forces, and then say which way you think it'll move. So 2 things. To get the net forces, it helps to break it up into vertical and horizontal. Let's see, so vertical, we got 200 and 196. So I'm going to let's see, if we subtract those, 200 minus 196 is 4, and 200 is a bigger force, so our net force will be 4 up. So I'm going to, as though we redrew this, with 4 up. Okay, now with our left and rights, we got 1 this way and 2 this way. Our net force then is 1 that way. So, alright, 1 Newton that way. So if this turtle is going, oh, we could totally, but I'm not going to. This turtle, if it's being pushed this way and this way at the same time, it's not going to go straight in between, but it's going to go somewhere in between because, you know, it's not going to just break or anything. If it's going 4 times more this way than this way, I would say that, you know, we could divide this into like fourths, and then it would go about right there. That's not even right. Like that, maybe? You think that's the direction it would go? That's what it's asking you to do on a couple of these, where you've got a net force this way and a net force this way, and you draw an arrow in the direction you think the object will move. That's what I did there. Oh, that's a pretty turtle, but we're going to have to erase it. I guess I'll turn the thing on first. No. Oh. This one. Okay. All right. So this time we have a craculator. We're going to have to draw a free body diagram and then do some math. So it says it's a -6 Newton craculator. That is its weight. That is its weight. Oh, here's my craculator. There you go, craculator. It's pushed across the desk. Okay, it's on the desk. That means they've got gravity here, gravity there, and it's -6 newtons. And we've got normal force here. And because we know gravity, normal force is opposite and equal. So if gravity is -6 newtons, that just means 6 newtons down. Then normal force will be +6 newtons. Doing this little translation between normal force and gravity is real important for figuring out this stuff, because it's going to make you mess with this new formula over here that I'll talk about real soon. And it'll give you this one and tell you to find the weight. Weight's not in this formula. It gives you normal force. So once you get normal force, you'll get a positive number. And then all you do to change it to weight is make it negative. Because these are the same as each other. They're just one's positive, one's negative. Does that seem all right? Good. That's what we're going to have to do here. So this time, it gave us the weight. And now we have to use the weight and translate it to normal force. So that's going to be one of our variables. Now let's keep reading here and I'll explain what all this new stuff means here. It says the coefficient of friction between the desk and the craculator is 0.3. Coefficient of friction is a new thing. It basically tells you how rough, how much friction there's going to be in between the two surfaces there. If it's a real low number, then it's not a lot of friction. If it's a real high number, then it's a lot of friction. But it's always going to be in between 0 and 1. And the reason for that is it's a ratio. See? It's a ratio of the frictional force, which would be, I guess I don't have frictional force drawn up here, but calculator's being pushed across the desk, so I would say that's applied force and that's frictional force. So it's a ratio of the frictional force to the normal force. And the more gravity you have, the more normal force you have. So, because this is newtons and this is newtons, coefficient of friction here doesn't have a unit, because newtons divided by newtons makes nothing. Newtons cancel, so it's just a ratio. So 0.3, just 0.3, that'll be fine. This little symbol here is called a mu, like the Pokemon. It's a Greek letter. This is a lowercase mu, and we use it, there's a couple of things it means in physics, but the only thing we'll use it for is coefficient of friction. And so get used to when you see this, that means coefficient of friction. Or when it asks for coefficient of friction, you'd be like, dang, what formula do I use? Oh right, this means coefficient of friction. Okay, so it told us the coefficient of friction between the desk and the calculator is 0.3. So frictional force is this way. It's trying to be pushed this way. That means that this surface is slightly rough right there. And I like to draw that little rough surface and then put my coefficient of friction in right there so that my picture has everything in it there. I've got my normal force and my gravity and my coefficient of friction, and I can see what's going on. And then I can write it over here. I mean, I guess I just wrote it, so I don't have to write it, but I'm doing it anyway. And now the question's asking me, what's the frictional force opposing the calculator's motion across the desk? So it's asking me for frictional force. There we go. Well, I've got three variables, and I've got three variables in my formula. Well, I don't have three, but it mentioned three variables, gave me two and asked for one, so I can totally solve using that formula here. Mu, or coefficient of friction, equals frictional force over normal force, where mu is 0.3, and frictional force is, we don't know, and normal force is 6. So, alright, we wanted to say equals frictional force. It says frictional force divided by 6 right now, so we'll multiply both sides by 6. Whatever, 6. 6 times 0.3. What's 6 times 3?
18.
6 times 3 is 18. So what's 6 times 0.3? 1.8. There we go. 1.8 newtons. And we're done. You got the frictional force. If you really want to, I can go add the word calculator to the dictionary. I know that's bothering some people. So here we go. I'm going to add it to the dictionary. And then, oh, and calculator is possessive, also a word. In here anyway. All right. There you go. You're welcome. So, yeah, I think y'all are good. That's all you'll need to do today. We'll work a more detailed thing tomorrow, a little bit. We're not doing much more.